All right, let's go ahead and take a look at question 3. We're actually going to solve this one graphically. You could definitely solve this one using some algebra, but we can use some pretty good calculator skills to look at this one. Here's what it says. The value of y varies with x according to this equation. Y equals a times x minus 2 times x plus 1. Then they tell us that a has to be a value that is less than 0. So when we think about values less than 0, we're definitely describing negative numbers there. As the value of x increases from 0 to 5, which of the following best describes the behavior of y? So we're saying as we change the input, the x values from 0 to 5, as those values increase, what's going on with the function? What's going to happen to the output? And we have a couple of choices here. So I've written on my paper what this function looks like, and I've put these different conditions here that we need to look at. Before we could put this in our graphing calculator, though, we have to go ahead and decide on a value for a. It's not going to be possible for us to enter a into the graphing calculator. Instead, we have to just commit to choosing a number here. So we want to make life easy on ourselves. Since it says that a can be any value that is less than 0, let's go with a nice easy number such as a equals -1. And so what I'm going to do is just replace a in my function with -1. And this is what I'll end up graphing in my calculator. Okay, just because the function's written in factored form, that doesn't change how we put it into the calculator. We'll go over to the y equals screen. Make sure you select the negative symbol. It's going to be -1, open parentheses, and we'll put in that first factor, x minus 2, close parentheses, then x plus 1, close parentheses, and let's go ahead and graph it and see what we have. All right. As predicted, we have a parabola that opens down because our a value is negative. It's a -1. And it looks like it's pretty, the vertex is over here in quadrant 1, but pretty close to the y-axis. What might be helpful at this point is to go ahead and change our window so that we can look very specifically at these input values, these x values ranging from 0 to 5. So let's adjust our window for this specific problem. We're going to click on the window button, and we're going to change our x minimum and our x maximum values. So starting here at x minimum, I'm going to hit the clear button, and I definitely want to be able to see the 0, but I don't want the 0 to be at the very edge of the screen, so I'm going to choose -1, a number just to the left of 0. I'm going to go down with my cursor and clear the x max setting, and I'm going to change it not to 5 but instead to 6. Again, I want to see these values, but I don't want them to be at the very edge of the screen. I'd kind of like to see what's to the left and what's to the right of it as well. All right, I'm not going to change anything else. I'm just going to hit graph. All right, now this shows us what's going on with the parabola up close. It seems like our vertex is located just as we predicted over here in quadrant 1. But as we go from x equals 0 to x equals 5, we can really get a picture of what's going on. So let's take a look at our answer choices and decide which one applies here. Our first choice is to say that the parabola increases and then decreases. So if we look at our function here, going from x equals 0 to x equals 5, it looks like the parabola is still increasing just a little bit until it reaches that vertex, which is the turning point. It's located right around here, and then it starts to fall again. So it seems like choice A is definitely going to apply to this particular parabola, but let's look at the other choices. Choice B says it decreases and then increases. With a parabola that is opening downwards, that would not be the case from here. It is not decreasing and then increasing. Remember, we read the graph from 0 to 5, from left to right, so B does not apply here. Okay, so choice C says that it increases only. That is definitely not the case here. The parabola is increasing only from the left boundary up to the vertex, which is the turning point. Choice D, it decreases only. That will be from the vertex to the right-hand side of the parabola. Since the input values that we're looking at go between the left-hand side of the vertex and the right-hand side of the vertex, that means it will increase for a short time and then decrease. Choice A is the correct answer.